For each of the following, find its recursive expression, find the expression for the nth term, and determine the 20th term in each sequence. Show your work. 3, 7, 11, 15. Well, first of all, I notice that that's arithmetic because the numbers are going up by adding 4 each time. So 4 is my common difference. The recursive formula, 2 parts. Always tell your reader what your first term is. And for an arithmetic, we go a sub n is equal to a sub n minus a 1, and then the common difference. We're adding 4 to go from one number to the next. The explicit, it goes a sub n is equal to your first number term plus the group n minus a 1 times your common difference. I'm going to clean that up. I'm going to distribute the 4, so that'll be 4n. 4 and the negative 1 make negative 4, and then the 3 up front, minus 1. The 20th term, I'm going to use that explicit formula, plug in a 20, so 4 times 20, 80, minus 1, 79. Number 6, 5, 20, 80, 320. I notice that these numbers are going up by multiplying by 4. That makes it geometric. My common ratio is 4. Recursive, always tell your reader what your first term is. And for a geometric, we say a sub n is equal to the ratio times a sub n minus a 1. An explicit, we say a sub n is equal to your first term times the ratio to the n minus 1 power. To find the 20th term, I'll plug in a 20. And that's 5 times 4, 20 minus 1 to the 19th power. And I typed that out just a second ago. And that was that big old number, 1374, 4895. I got the 4 already, 3895. 34720. Find the sum of the numbers in the following sequences. Use your formulas. Number 7, 80, 81, 82, 83. This is arithmetic. I notice that the numbers are going up by 1. To do an arithmetic sum, you need 3 things: your first number, your last number, and how many numbers you're adding together. From 80 to 180, that is 101 numbers. Okay, if that confuses you there, remember the formula for figuring out how many numbers you have. You take your last number, you subtract your first one, you divide that by your common difference, we're going up by 1, and then you always add 1 at the end. Adding that 1 is something some people forget to do. So to figure out the sum of these 101 numbers, here's your formula for arithmetic. You take the number of numbers, number of terms, you divide that by 2. You multiply that by the group, first number plus last number. And we get 13,130. Number 8, 2 plus 5 plus 8 plus 11. That's arithmetic also. I need to know my first term, my last term, and how many numbers am I adding. This one I'm going to use my formula on. I'm going to take my last number, subtract my first number. Because these numbers are going up by 3, I divide by 3. And then I don't forget, always add 1. 527, take away 2. I'll divide that by 3, and then I'll add 1 to that. 176 numbers. So the sum of these 176 numbers is 176 divided by 2. The first term added to the last term. 46,552. The first 20 terms in, 5 plus 10 plus 20 plus 40. This is geometric. And it's a finite series because we're doing a set number. To do a geometric, you need to know your first term. What are you doing from one number to the next? So our common ratio here is going to be 2 because we're multiplying by 2. And we need to know how many terms. The formula for this goes like this. The sum of these 20 numbers is equal to your first term times the grouping 1 minus the ratio to the 20th power, how many numbers you're adding together, and you divide that by 1 minus the ratio. And number 10, all of the terms. So this is an infinite. And we're only allowed to do infinite as long as the numbers are getting smaller. So we have 5 as our first one, 5 over 3, 5 over 9. So we are dividing by 3. So your common ratio is 1/3. The numbers are definitely getting smaller. So the sum of all of these terms, here's your formula for that. You want your first term divided by 1 minus the ratio. If 1/3 can be turned into a nice decimal, I would do that, but you can't turn 1/3 into a nice decimal. So 5 divided by, parentheses, 7.5. I hope that helps.